Everyone, welcome to Aviation Engineering YouTube channel. So this is another lesson. So maybe most of the people is waiting for this lesson. This is about AD chapter 71 power plant, IAE V2500-A5 engine. So in the previous lesson I discussed about the general thing. So today I'm going to discuss about the power plant drain presentation and nacelle description and operation. So this video will be a little bit longer because I took two lessons of this video. So just if you're interested about engine, especially IA V2500, just watch this video, because this video I will give you more information, especially nacelles description and operation. All right, so if you still not subscribed to Aviation Engineering YouTube channel, please subscribe. Please share these videos with your friends, relatives, anyone who like to learn about aircraft maintenance engineering. Especially if you're interested about engines, someone who like to learn about aircraft engines, just share this video. All right, okay, now let's go to the video. All right, yeah, so this is the lesson 88 chapter 71 power plant. So IA V2500-A5 IA V2500-A5 engine. So today I'm going to discuss the power plant drain presentation and nacelle description and operation. All right, so the lesson contained as the number one, power plant drain presentation. Under power plant drain presentations, I'm going to teach you about the general and the pylon drains and the engine drains, and then the nacelle description and operations. Yeah, under this one have so many chapters, so that's why I said the lesson will be a little bit longer. So the initial I will going to talk about the air intake cowl and the fan cowl doors, left and right hand, thrust reverser C-duct, common nozzle assembly, exhaust cone, forward mount, aft mount, fluid disconnect panel, fan electrical connector panel, and electric junction box. All right. Okay, you can see this is a normal picture I took from the internet. All right, so this is the IA V2500-A5 engine. All right. Okay, so let's go to the first one, power plant drain presentation. Okay. All right, the purpose of this section is to explain how the engine drain system is designed and how it's work. So the engine drain system removes excess fluid, oil or fuel from the engine. Okay, just remember the engine drain system, why we use it? We use it to remove excess fluid like oil and fuel from the engine. And this system includes a series of pipes and valves that directs the fluid safely away from the engine to prevent damage. Okay, understanding the system is crucial for maintaining engine performance and safety. All right, so let's go to the first one, general. Okay, you can see this is the drawing. Okay, you can see this is the engine. You can see the lower in the lowest point they have the engine drain. Also in the this is in the pylon drains. Okay, so the power plant drain system gathered fluids. Okay, the power plant drain system. Okay, the power plant drain system gathered fluids that might leak from different part of the engine. It means inside the engine all covered, right, from the nacelle. So the power plant drain system, they gathered fluid that might leak from the different part of the engine, including the pylon, engine, accessories and drives. So these fluids could be oil or fuel or other liquid. This system, the system used pipes and valves to channel these fluids away safely, preventing potential damage or hazard. Okay, so so these fluids discharge overboard from the pylon drain and engine drain. Okay, it means inside the engine, if they have some problems or some overfill or oil or fuel, something is drained, so this one cannot keep inside the engine, so we must drain it from the engine. So for draining purposes, that's why we are using engine drain system. Okay, that is the general idea. Okay, now let's go to the pylon drain. The pylon drain, okay, I told you they have two drains, engine drain and pylon drain. So now the pylon drain, you can see this is the pylon. Okay, yeah, you can see this area is called the pylon. And okay, so you can see the pylon primary structure is here. Okay, primary structure, and yeah, this is the secondary structure, primary. Okay, right, so the engine pylon is split into 7 sections. Okay, you can see like in here you can see the sections are zone A, B1, B2, C, D, E and F. Okay, here you can see, right, A, B1, B2, F, C, E, F. Okay, these are the 7 sections, each housing different system, each housing using different section, and these systems run through these compartments to ensure the engine functions correctly. And any leakage from fluid lines are drained. Okay, any leakage from the fluid lines are drained overboard through separate lines in the rear of the pylon. It means any leakage happens inside this section will be drained overboard through the separate line in the rear of the pylon. Okay, this is the actual picture. You can see these are one, two, three lines over there, pylon drain. So if anything drain inside this area, will be overboard through pylon drains. Okay, these 3 lines. Okay, you can see the designations and the system, the zone wise. You can just, I will give you an idea, like forward fairing A, B1 and B2, like A, B1 and B2, the flammable fluids like fuel, hydraulics, bleed air, H1, or high pressure and low pressure temperatures, and electrics like this. Okay, and these are the systems, right? And the pylon box C, hydraulic fire extinguisher bottles, right? Hydraulics fire extinguisher systems. You can see here hydraulic and fire extinguisher bottles, and the rearward secondary structure here, the rearward secondary structure D, hydraulic and limited electrics. And the lower fairing, you can see number E. Yeah, here is the lower fairing. Lower fairings don't have anything, right? None, and no systems. And the pylon to wing center fillets, pylon to wing F, right? Pylon to wing center fillers, right here, right? And is fuel, zero leakage couplings, and electrics and bleed air, low temperature. These are the systems they are using. Okay, all right. Now let's go to the engine drains. Engine drains bit complicated. Okay, actually it's not complicated, but the diagram you can see here, the engine bleed. I will show you. This is the drain mast. Drain mast is like this. Okay, you can see the actual picture, drain mast. So drain mast, you can see the oil tank scupper, oil tank scupper will come over there, and the fuel pump also here, and the fuel metering unit. All the excess fuels will come to the drain pump, drain mast. Okay, and also you can see full diverter valves, and here these are the low pressure booster bleed actuator and variable stator vanes actuator, and active clearance control actuator, low pressure booster bleed valves actuator. Okay, and also air cool oil cool actuator over there, and integrated drive generator, hydraulic pump, and air starter valve. Okay, this is the right side. Okay, right side, and you can see these are the pipes, right? So here is the main gearbox is located in the engine, and here is the angle gearbox also there. So remember, the drain mast situated near the angle gearbox, and this is the collector plate assembly, and here's the gasket. Here have a gasket also, and the drain mast, and this is the fan case. Okay, when you see, this is like a forward beam. So these connections are at this accessory mounting pads only, right? So the fluid from the oil tank, fuel diverter valve, and the gearbox accessories is separately channeled to the drain mast, separately channeled. Okay, so this means each source of fluid is directly individually to the same place for safe disposal, ensuring proper handling of all fluids. So the fuel drain from the core engine accessories are routed through the separate drain lines, which passes through the bifurcation panel. Okay, so let's see what is bifurcation panel. Maybe this is a new word for you, right? So it is divide fluid or air flow into 2 separate parts, ensuring proper distribution and management in system. Okay, that is the engine drain. So I told you 2 drains, pylon drains and engine drains. Okay, pylon drains, they collect all the excess fluid disposed in the pylon area, and this is all the fluid exposed in the engine area. So they have 2 drain points, pylon drains and engine drain. Yeah. Okay, that's all for the draining system. Very easy, right? So now let's go to the nacelle description and operation. Nacelle description and operation. So you can see this is the nacelle. Okay, this is nacelle area, right? So this section describes in detail the different items of the nacelle. Okay, now the thing starts. So don't skip this thing. You just watch. Okay, this will be good knowledge for you. All right. Okay, the first one, air intake cowl. Okay, here is the engine. This is called the air intake cowl. Okay, you can see so many things inside the air intake cowl. Okay, you can see. Okay, let's see From the front side, when we see the front side, here you can see P2 T2 probe. It means pressure and temperature probes. And here the P2 T2 probe access door. It is in the top. And the pylon cap. Here is the pylon cap. And you can see the forward bulkhead. Forward, they have a bulkhead also inside. Like this is the forward bulkhead, and this is the aft bulkhead. And inside this one, you have an inner barrel. And you can see the outer skin, air intake lip. Okay, here you can see the thermal anti-ice separating tube following the air intake lip. Okay, they have thermal anti-ice separating tubes also. Okay, and anti-ice supply exhaust ducting assembly. All right, so yeah. And also, if you go count, when you see from the aft side, you can see these are the alignment dowels. They have 4 alignment dowels. When we install, very easy, we have to use this one. And this is the door locators, and the nacelle zone 1 fan compartment ventilation intake. This is the T2 probe. Okay, electrical connector. The T2 probe, they must be come from electrical connectors. So the electrical connectors come here. And here has the door locators. Okay, door locators. And yeah, these are the hoisting points. Hoisting points we are using when we remove. Okay, because this is heavy. And bracket, two places from fan cowl hold open struts. Okay, these used to put the hold open rods. And the interphone jack, interphone jack specially we are using to connect with the ground to cockpit. And anti-ice exhaust panel, anti-ice. Okay, because inside here the anti-icing is also having anti-ice ducts. So when the bleed air comes inside the anti-ice, there should be a place to these airs to remove. So this why they have the anti-ice exhaust panel over there. And anti-ice discharge bridge. All right, this is the anti-ice supply duct. Okay, this is the anti-ice supply duct. And this is the door locator again, the engine and anti-placement ring. Here is the anti-placement ring. Okay, all right. So actually I want to tell one, in this lesson I'm not going to tell you what is the purpose of this one component and what is this blah blah like this, because I don't yeah. All right. Okay, so actually I just tell you, like, if you want one by one, just comment below, then I will give you another lessons, especially these kind of special items. I will tell you what is the purpose of this one, like this. Okay, so but in future lessons I will take some components and I will describe what is the purpose, especially for system in this component, what happened. So this kind of things I will take in future. All right. Okay, so let's see. The air intake cowl is attached to the front of the fan case using bolts. Okay, actually this one is connected to the front of the fan case using bolts. This cowl helps direct air into the engine. It has an anti-ice system to prevent ice buildup that could block airflow, ensuring the engine runs smoothly in cold conditions. Additionally, it features an interphone jack for communication between cockpit and the maintenance personnel. I told you, here is the interphone jack. The P2 and T2 probes. Okay, here the P2 and T2 probes is a sensor that measures the pressure and the temperature of the incoming air. Okay, remember when the aircraft is like this, the air goes like this. Okay, you can see this cursor. Okay, you can just go your eyes to the cursor. If the airflow comes to the engine, and the pressure and the temperature in the air is sensed by the P2 and T2 probes. Okay, incoming air provides crucial data for the engine performance and efficiency. All these features work together to maintain optimal engine operations and safely. Okay, all right. So for removal and installations, the inlet cowl is provided with 4 hoisting points. They have 4 hoisting points for removal and installation and 36 identical attached fittings. Here are the 36 identical attached fittings and 4 alignment dowels. Okay, you can see they have 4 alignment dowels. All right. Okay, the weight is 238 labs. It means 108 kilograms. So that's why they use the hoisting points to put it using the crane. Okay. All right. So the next one is the fan cowl doors. Fan cowl doors. Okay, you can see this is the fan cowl door. Okay, this is the layout. You can see in the fan cowl doors also AC, air cooler, oil cooler, cooling outlet over there. Okay, cooling outlet over there. And yeah, in this photo, so cooling outlet is in the right side in the engine. And Yeah, and the hinge fitting on each side of the pylon. These are the hinge fitting. They have 4 hinge fittings. And aerodynamic strike. Okay, I will tell you later what is aerodynamic strike in both side only. So aerodynamic strike is there only in the inboard side of the engine. Okay, in the left side it means in the left engine. This one is in the right side, and the right engine, it's one in the left side. It means inboard side. So the left hand fan cowl door and the hoisting point, they have the fan cowl also have 2 hoisting points and quick access master chips, master chip detector. Chip detector is there, magnetic chip detector. Okay, and here is the quick access oil fill and side glass pressure relief door is there. Right, you can see the ventilation grid adjustable keeps up, and yeah, this is the adjustable keepers, and this is the ventilation grips, and these are the latches, 4 latches over there, and old open rods. Okay, you can see we hold open rods over there, store in there, and wheel case breathe outlet. Okay, wheel case breathe outlet over there, and these are the door alignment features and air starter valve access pressure relief doors. Okay, this is right hand fan cowl door. So, okay, let's see there are 2 fan cowl doors that allows access to the fan case and accessories mounted on the gearbox. So each door is supported by 4 hinges. I told you they have 4 hinges. 4 hinges attached to the pylon, which in the part of the aircraft structure that holds the engine. The door are secured along the bottom center line with 4 latches. Okay, you can see this one is secured from 4 latches. Ensuring they stay closed during flight but can be easily opened for maintenance. Actually, this is very good latch, but when the aircraft is down, we can open it for the maintenance. So each door is provided with 2 hoisting points for removal and installations and 2 hold open struts for opening. Each door got 2 hold open struts for opening. So the access doors are also provided for the starter valve and the oil tank servicing. They have access doors also provided for starter valve and tank servicing. Note that aerodynamic strakes are fitted on the inboard nozzle. Okay, this is very important, just remember. So the left hand door weight is 79 labs. Okay, it means 36 kilograms, and the right hand door weight is 86 labs, 39 kg. Okay, just remember. All right, so now let's go to let's go to, you can see the fan cowl strake. What is fan cowl strakes? Why we are using this kind of thing? So the fan cowl strake is an aerodynamic component attached to the fan cowl of an aircraft engine. So it is used to manage airflow around the engine nacelles, reducing drag and improving overall aerodynamic efficiency. So the strake helps to direct the airflow smoothly over the engine components, minimizing turbulence and enhance the engine's performance. Okay. So by optimizing the flow of air, the strake reduces noise and vibrations, contributing to the quieter and more efficient operation. So additionally, it helps in maintaining stable engine performance by preventing unwanted air disturbance that could affect the engine's operation and efficiency. Okay, now I think you got an idea about what is fan cowl strake. Okay. Alright, now let's go to the next one, thrust reverser C-duct. This is also a very important part in the nacelle. Okay, this one also have so many things. You can see C-duct hinges. They have hinges, 4 hinges in each side, and C-duct opening actuator. Okay, this is the C-duct opening actuator over there. And upper bumper 4 places are there, 4 places, and pre-cooler duct. Okay, here is the pre-cooler duct. And cascade hidden behind the translating sleeves. Inside the translating sleeves, they have cascade. Okay, here is the thrust reverser. In the here this area have the cascades. Okay, cascade vanes. Okay, right. And this is the translating sleeve, 2 places over there, and translating store lock nut, and translating sleeve pin storage over there. It means store lock nut take and pick the pin storage, and translating actuator also there, and flex hose quick disconnect fitting. Here it means this is used to manually open the C-duct from the hydraulic pump. Yeah, so the C-duct latch, they have 6 spaces. Lower bumper 5 places, translating lower actuator 2 places, and inner barrel. This is the inner barrel, and handling bleed valves, air discharge holes over there. Here, the 3 discharge holes, right? Bleed valve, air discharge holes, 3 valves, and translating upper actuator 2 places over there, and torque ring. Okay, here is the torque ring, and upper track beam and hinge fitting. Okay, you can see this is the real actual picture. You can see this is the translating thrust reverser C-duct, is bit heavy. Okay, so the thrust reverser C-duct are divided into two halves. Thrust reverser C-duct total divided into two halves, each equipped with cascade blocker doors and translating sleeves. Cascade guide the airflow blocker doors prevent air from bypassing the reverser, and translating sleeves helps adjust direction of the airflow. Each half of the C-duct is mounted on four hinges attached to the pylon, allowing for movement and operation. All right. So the half assembly is latched along the bottom center line with six latches. Remember, these two C-duct two halves are latched from the bottom, same like the fan cowl, right? This one also latch from the bottom from six latches. Okay, the previous one, this one fan cowl is latched from the four latches, but the C-duct is latched from six latches. Okay, so the left hand door weighs 580 laps. It means 263 kg is very heavy, and right hand door weight is 574 laps. It means 260 kg. So the C-duct in thrust reverser system redirects the engine exhaust flow. Remember, the C-duct in thrust reverser system redirects the engine exhaust flow forward to help slow down the aircraft during landing. You can see when you sit in the actually, if you're not a maintenance person, if you just watch this video, you can see like if you sit near the window seat, when you see the engine, when the aircraft is suddenly landed, you can see some doors open and very big sound is coming. So that is the translating sleeve, and the thing they are doing is exhaust flow forward. It means the exhaust flow coming and it's turned the forward flow to forward, so then there should be a drag will be increased. Okay, so the forward flow to help slow down the aircraft during landing. So it uses cascade and blocker doors to control the direct the airflow, enhancing braking efficiency and reducing stopping distance. Okay, right. Yeah, so again, like you can see the from the app, when you see the C-duct from the aft, here is the flex hose quick disconnect fitting. Okay, flex hose quick disconnect fitting, and this is the place we put the hand pump and we manually pump, and then the C-duct will be up. Okay, sorry, and this is the forward and aft hold open rod. So when the C-duct is open, and then we hang it through the hold open rod, because it's very heavy, it can come down. Okay, and this is the right C-duct, and this is the flex hose. Flex hose is mean like when we open fully, and if we do like the engine change or something, we need to put this one to hold the C-duct, because we cannot use this for forward and aft hold open rods, because why? When we remove engine, it's like no access then, right? And this is the heat access panels, and this is C-duct opening actuators. Okay, and the wave locking from the front of the engine. Okay, and this is the hydraulic tube, right? Yeah. So each half is provided with every half is provided with 3 attachment points for handling, and 1 open actuator operated with hand pump, and 2 hold open rods. And the latch assembly consists of forward bumper latch, 3 center latches accessible through the hinge access panel, and 1 aft twin latch. Okay, you can see the thrust reverser C-duct latches. They have 1, 2, like this, 6 latches are there. All right. Now let's see the hand pump connection. Okay, I told you this is the hand pump. Okay, we use this one to connect the hand pump, and this is the real location. You can see. So okay, the open the C-duct using the hand pump, there are the follow steps, like locate the hand pump. First we have to locate the hand pump, find the hand pump, which is typically positioned in the maintenance or emergency access area. Actually, we have to borrow from the tool store. And connect the pump, ensure the hand pump is properly connected to the hydraulic system of the thrust reverser, and operate the pump. Turn the hand pump handle to manually pump hydraulic fluid into the system. This action pressurizes the hydraulic fluid. Activate the C-duct. As the fluid pressure increases, it moves the C-duct component such as cascade and blocker doors to the open position. And monitor the movements, check the C-duct is fully opens and properly aligns, ensure that all components are function as expected, and disconnect the pump. Once the C-duct is open, safely disconnect the hand pump from the hydraulic system. So this is the theoretical way, but when you do it practically, actually we don't need to go through like this. You just take the hand pump and connect, and we pump, the hand pump, and the C-duct is going to be open. After you is open in the desired level, we connect the hold open rods. Okay, right. So now let's go to the common nozzle assembly. Common CNA means common nozzle assembly, also very important. You can see the upper strut over there, and the C-duct inner barrel is there, and translating sleeve rear seal. Okay, translating rear seal is there, and the right side strut and the inner duct. CNA mounting flange. This is the CNA common nozzle assembly mounting flange, and CNA load share fitting. This is CNA load share fittings, and this is the left hand side strut and lower strut and outer duct, hoisting points 4 places, and common nozzle fairing, and vector exhaust nozzle, vector exhaust. This is the vector exhaust nozzle, and this is the fireproof bulkhead. In the upper, the pylon and the CNA, they have a fireproof bulkhead, because when the fire is coming, because when the engine is running, the common nozzle assembly open for very high temperature fire, so there should be a fire bulkhead. Then the fire will not go to the pylon, because the pylon, the fuel lines, everything go through the pylon. So if there's a fire, and it's easily can happen, go to the fuel tank, very dangerous. Okay, all right. So the common nozzle assembly, actually this is the real view common nozzle assembly, and the common nozzle assembly combine exhaust gases from both primary and secondary airflow of the engine. So this component is bolted to the rear flange of the turbine exhaust case. The primary airflow comes directly from the engine's core, right? Primary airflows comes directly from the engine core, while the secondary airflow typically includes bypass air from around the engine. So the nozzle mixes this nozzle, common nozzle assembly mixes these gases to ensure a smooth and efficient exhaust flow. So by combining these two types of air, the assembly helps to control the engine's thrust and reduce noise, contributing to better overall performance and efficiency of the aircraft. Okay. So the common nozzle assembly attached to the low pressure turbine frame. Okay, this one attached to the low pressure turbine frame by means of 56 balls. Okay, just remember 56 balls, and the weight is 181 labs. It means 82 kilograms. Okay, right. So now let's go to the exhaust cone. So yeah, this is exhaust cone, very small. This is the mounting flanges. You can see this is like a plug. This is the common nozzle assembly, exhaust cone inside the common nozzle assembly. So the exhaust cone is a part that shapes the path of the exhaust gases coming out of the engine. Right? It is fixed to the inner flange of the turbine exhaust case. This is fixed to the inner flange. This is the inner flange. Okay, this is fixed to the inner flange of the turbine exhaust case, which is the part at the rear of the engine. So the cone purpose is to create a smooth and controlled flow of exhaust gases. So by doing this, it helps reduce turbulence and guide the gases effectively out of the engine. This improves the overall efficiency and performance of the engine by ensuring that the exhaust gas exits in a streamlined manner. Okay, this improves the overall efficiency and performance of the engine by ensuring that the exhaust gases exist in a streamlined manner, which also contributes to better fuel efficiency and lower noise level. Okay, and the exhaust cone is bolted into the inner low pressure turbine frame by means of 13 bolts. Okay, this one connected to the low pressure turbine frame by using 13 bolts, and the weight is 10 labs. Very light. Is okay, we can lift from our hand. It means like 4.5 kg. All right. Okay. And now let's go to the next one, is the forward mount. Yeah, forward mount also very important. Okay, right. Okay, so you can see the forward mount. Some people can see, especially the maintenance personnel can see this one, but if you are a passenger, you cannot see this one, the forward mount. So that's why in this video you can see what is this. All right. Yeah, the forward mount, you can see this is the forward mount. Right. So yeah, this is the view. You can see the forward mount. Here is the beam assembly. This is the beam assembly, and this is the fail-safe bolt position. They have a fail-safe bolt. Okay, this one is fail-safe bolt position, and this is the pylon mount bolts. Pylon mount bolts, they have this. They have 4 places. Pylon mount bolts, they have 4 places, and this is the cross beam assembly. They have cross beam assembly. These are the alignment shape pins. Okay, if there's some torque load or something, this one will be broke. Okay, alignment shape pins. And this one, thrust link assembly. They have two thrust link assemblies, and this is the engine forward support shaft. This is the engine forward support shaft and support bearing assembly, and this is anti-rotation and retaining place. They have 10 places, anti-rotation and retaining place are there. All right. Yeah, this is the pylon forward mount. This is the pylon forward. Okay. All right. So yeah, this is the engine forward engine mount. You can see disconnected here. Okay, you can see like this. All right. So the forward mount is critical component that support the engine by carries various type of loads, including thrust, vertical loads and side loads. Remember, the forward engine forward mount, they carry thrust, vertical and side loads. It is installed it is installed on the intermediate case. Okay, remember, forward engine mount is installed on the intermediate case, which is positioned at the top center of the low pressure compressor. Okay, just remember this one. The forward mount is secured in place by the engine forward support shaft. This shaft connects the mount to the engine structure, ensuring stability and proper alignment. By managing these loads, the forward mount helps to maintain the engine's position and alignment with the aircraft, contributing to overall stability and performance during operation. Okay, right. So the forward mount is composed of four main parts. Okay, the forward mount is composed of four main parts. They have two thrust link assemblies. You can see they have two thrust link assemblies and two beam assembly. Okay, you can see a beam assembly is there. Okay, you can see this is the beam assembly and the cross beam assembly. This is the cross beam assembly and a support bearing assembly. That is they have a support bearing assembly. Okay, you can see this is the support bearing assembly, and the forward mount is made to be fail safe. Remember, the forward mount also be made to be fail safe. It is linked to the pylon forward part with 4 bolts and self-locking nut. Okay, this is linked. This one is linked to the pylon from 4 bolts and self-locking nut also. All right. Yeah. If I have some if I have some chance, I will try to take a small short video how to install the forward mount to the engine. Okay, actually this is a little bit difficult, especially V2500 engine. So let's see, if I have a chance, I will show you in 320, right? All right, so the next one is F mount. Yeah, F mount is here. Yeah, this is the F mount. This is also very heavy, right? F mount is also there. So you can see the F mount. This is the pylon F part. This is the pylon F part and engine version adapter, and this is the pylon mount 4 places. And the alignment shaping, here is the alignment shapings and the beam assembly. This is the beam assembly. This is the side link assembly. This is the side link assembly, and the turbine exhaust lugs, and the barrel nut. They have 4 barrel nuts, 4 places, 4 barrel nuts, and center link assembly. They have a center link, and this is the turbine case and the anti-rotation and anti-retaining plate, and side link assembly, alignment pin share 2 places. Okay. All right, so let's see, the F mount support the engine by handling torque, vertical loads and side loads. Remember, the F mount, they take engine torque, vertical loads and side loads. It is designed to be flexible in the forward and aft directions to accommodate engine thermal expansion, which occurs when the engine heat up during operation. Just remember, and the flexibility helps prevent damage from the thermal stress. The flexibility helps to prevent damage from the thermal stress. The F mount is attached to the lugs on the turbine exhaust case, which are robust fittings at the rear of the engine. This setup ensures that the engine remains securely in place while allowing for necessary movements due to temperature changes. The F mount is composed of 3 main parts. Okay, you can see the beam assembly. This is the beam assembly and the 2 side link assemblies. Okay, they have 2. This side and this one, they have 2 side link assemblies, and the center link assembly, this one have a center link assembly. The F mount is made up of fail-safe. This one, aft and forward both made to be fail-safe, and the link is to the pylon F part with 4 bolts. Okay, this one also linked by 4 bolts. Okay, but they don't have self-locking nut. Okay, all right. So yeah, actually in this one, when we install, they have a high torque load. Okay, normally 2 or 3 persons we need to torque. All right. Okay. Yeah, maybe this one also, if I have a chance, I will take a video how they talk. All right. Yeah, next one, the fluid disconnect panel. This one also very important when we remove the engine and installations of the engine, right? This is the fluid disconnect panel. Okay, what type of fluids? They have two type of fluids, fuel and hydraulic. Oil we don't put like this. Okay, fuel system and hydraulic system. The fuel system, we can see the fuel supply, fuel return valve. In the hydraulic system, they can see hydraulic pump suction, and the hydraulic pump pressure delivery and hydraulic pump case drain. You can see the pipes. Okay, the big one is for the hydraulic suction, and then the small one hydraulic pressure, and this one hydraulic case drain. These are the hydraulic things. And the next one is the fuel return to tank, and this one is fuel supply. Okay, you can see this is the fluid disconnect panel. The big one is this is the quick release one, and this is the, remember, hydraulic suction line. Okay, all right. The fluid disconnect panel establishes the connections for fluid lines between the engine and the pylon, which is the structure supporting the engine, located on the upper left side of the fan case. Remember this one, it means this hydraulic lines is located on the upper left side of the fan case, upper left side of the fan case. So this panel allows for easy disconnections and reconnections of the fluid lines for maintenance and removal of the engine. So the panel ensures that essential fluids such as hydraulic or fuel systems are properly linked and can be quick reconnected or serviced when needed. Okay, right, you can see this is the pylon and this is the fluid disconnect panel here, and these are the fan case. Okay, just imagine these are the things inside over there. I told you before. Okay, now next go to the fan electrical connector panel. This is also a bit complicated, and especially if we are a B1, you don't need to know a lot about this thing. But if you're a B2 person, this must be very critical. I mean, you must know about these things, right? Okay, you can see the fan electrical connector panel serves as the interface between the electrical harness of the fan and the pylon, which supports the engine. Okay, so many things you can see, like FADEC reset channel B over there, and the TLA extractions, right? N2 to engine vertical monitoring unit, right? Trim balance sensors. Okay, actually I also not more familiar with these kind of words because of this B2, right? All right, so if you like, you just pause this video and just take a, you can look after this, what is this, like this. Okay, all right, this is the panel. Okay, and the positions on the upper right side of the fan case. This is also in the upper right side of the fan case, right? These panels allows for the connections and disconnection of electrical wiring. So it ensures that electrical systems such as sensors and controls are properly linked for operations and maintenance of the engine. Right? Yeah, the last one is core electric junction box. Core electric junction box. Okay, in the aircraft also, in the core side also have a electrical junction box. Okay, you can see this is situated over there, right? Here, the, like you can say, HP valve, pressure regulating valve, 450 voltage. Okay, here HP valve, pressure regulating valve, the core fire detector loop B. Okay, I will talk about the loops, loop A, loop B, from in the IAE chapter 26 fire extinguishing. This chapter I will describe about fire detector monitoring. I will describe about loops. Okay, all right, so this is the core fire detector loop A, Nacelle temperature sensor. All right, this is the core fire detector B, loop B, and this is loop A, Nacelle temperature sensor, and this is the pilot forward part. Okay, so the core electrical junction box serves as the interface between the core electrical harness of the engine and the pylon. So positions in the forward mount zone. This box allows for the connections and the organization of the electrical wiring. So it manages the distributions of electrical power and signals between the engine and aircraft pylon, facilitating proper operations and maintenance of the engine electrical system. All right. Okay. Yeah, that is the end of the lesson. So I think we took around very more time for this lesson because I want to describe. So I think you got a good knowledge, and actually thank you for participating in these lessons as Aviation. So if you still not subscribed to Aviation Engineering, please subscribe, please share these videos with your friends, relatives, anyone who like to learn, because this is the IAE chapter 71 module. So if you want to learn more, you can go to my playlist. They have hundreds of videos regarding A320, especially 2021, and later onwards I will try to take Boeing 777, because these days I'm working on Boeing 777, so I'm still learning. So after I got my type training, I will teach you what is Boeing 777, and I'll give full descriptions. Just waiting for this one, and please subscribe this channel. Okay, that's all, and see you on next video. Have a good day for all of you.